Today we're starting chapter 6, which is differential equations and mathematical modeling. And today we're going to start out with section 1. And the first half of it deals with differential equations and initial value problems. We call differential equations DiffEqs. And in fact, in college, there is an entire semester class based on differential equations. All right, a differential equation is simply an equation that has a derivative in it. A derivative equation, that's all it is. This is called Leibniz notation. We actually haven't talked a lot about the founders of calculus, but Leibniz is one of them. And he made up this dy over dx symbol or terminology right here. So we use that terminology to write a differential equation. These are both examples of differential equations. Our goal is to solve them, okay? And we want to solve them. There are two kinds of solutions. One is general. That means you just have a plus c on it. And a particular solution means you have a specific number, like a plus 6 at the end of your solution. So we take the antiderivative, either add a c, which is a general solution, or add a number. Now, if we have a number, this is called an initial value problem. Okay, to solve, we take the antiderivative of both sides of the differential equation. So let's do it. Okay, so taking the antiderivative of both sides looks like that. Just put a little integral sign. Hopefully Mike Russum can handle this. Anyway, y equals, when you take the antiderivative of dy dx, you just get a y. The antiderivative of cosine squared, make sure you have these things memorized, is negative cotangent. And then 2x, we have 2x, we add 1 and divide by that number. When you have the antiderivative of 5, that's 5x. And then you add a plus c. That is your answer. That is solving the differential equation. We might want to clean it up by taking off these 2's and just clean it up a little bit. Plus x squared plus 5x plus c. All right, and that is your solution to your differential equation. This is called a general solution. Oops, except you have to be able to spell. A general solution. That's because we don't have a specific number for c. We just add a c constant. Okay, the next one is also, this is a differential equation. We want to solve it. Remind me to play this little thing in class because it's funny. All right, anyway, we're going to multiply. Before we start, we're going to multiply 2u times both of these terms to make this easier for us. Dy over du. And this is just, instead of using an x, they're using a u as their variable. So 2u times u squared is 2u cubed minus 2u. All right, let's take the antiderivative of both sides of that equation to solve our differential equation. We have 2u, we add 1 and divide by that number. And then we're going to do the same thing here with 2u. We add 1 to the exponent, divide by that number, and then add a c. So again, we're done. Just clean it up and call it a general solution. U to the 4th over 2 minus u squared plus c. Or you could write 1/2 u to the 4th. Again, this is a general solution. Okay, next we're going to look at what are called initial value problems. These give you a particular solution, and they are always on the AP exam. This gives you a particular solution because it gives you a starting point for where your general function starts. Okay, so we're going to solve this problem. And instead of using x and y, we're using s and t. Okay, so yes, actually I write it the opposite way. time, and distance. So I'll write it like that. 0, 1 is our point. All right, so what we do is we take the antiderivative and then we plug in our x and y, or our t and s. So we have s equals, because we're taking the antiderivative of both sides. We have t, add 1, which is cubed, divide by 3, plus t plus c. All right, so we have this differential equation solved with a general solution. Now we have to find the particular solution when time 0 equals 1. All right, so we plug in a 1s, and for the t, we plug in a 0. 0 cubed over 3 plus 0 plus c. Therefore, this is nothing and this is nothing, therefore c must equal 1. So our particular solution is going to be this equation with c implanted. So s equals t cubed over 3 plus t plus 1. That is solving an initial value problem. That's what they're called, initial value problems, because they give you an initial value. Like at time equals 0, the position is 1. And this is a particular solution. It's not a general one. It doesn't have a plus c. We actually solved for c. Okay, so one more of these. Let's take the antiderivative of both sides. And this time we have x0, y4. So we know that this function starts at the point 0, 4. All right, solving the differential equation, or the diffie-q, the antiderivative of cosine is a positive sine of x. Do not forget c. When you have a derivative that doesn't have a lower limit and an upper limit, you always have to have a c on it. Okay, now we know our initial condition. So x is 0, y is 4. 4 equals 0, plus sine at 0 plus c. All right, so sine at 0 is also 0, so that means that c equals 4. All right, these two are both zeros, so c equals 4. Therefore, our solution is to our initial value problem, x plus sine of x plus 4. Voila! That is our solution, and that is the world of differential equations. Like I said, there is an entire semester spent on learning differential equations in college. Wow, an 8-minute video must be a record. See you next time.